Hello and welcome to another problem-solving session with Special Maths Academy. We'll be looking at problem 20 of the first round of the Nigerian Mathematics Olympiad 2020 for the senior category. So let's jump straight into the question. So this is the problem 20 and it says, let n be a member of the set of natural numbers, so basically positive integers. So n chairs are arranged in a row. A number of persons are said to be seated in a comfortable arrangement if they are all seated with no two sitting on the same chair and no two sitting on adjacent chairs. Let xn denote the total number of possible comfortable arrangements on n chairs. So basically, no two seated on the same chair and no two seated on adjacent chairs. So basically, they are social distancing, probably because of the times. That was a joke. Okay, so note that each comfortable arrangement must have at least one person. Okay, so there at least someone must be seated on the row of chairs. So which of the following is not a possible value of x of n? So basically, we want to find products of this x of n. So let's dive straight into that question. So let's say we have the chairs. Let me make this bigger. Okay. So let's say we have the chairs, n of them. So I'll just label the chairs, the first chair, second chair, third chair, fourth chair, and so on and so forth. So this would be n minus 2, n minus 1, and nth chair. So I want to find xn. Basically, we're going to go by looking at it, trying to see if we can relate xn to other values of x's. So sort of you can see how we can relate xn to xn minus 1 and so on and so forth. Okay, so we're going to count the number of ways of sitting arrangement. We'll take n cases, okay? So the cases. So we're going to take n cases. So case 1, if the first chair occupied is chair 1. So chair 1. Case 2, first chair to be occupied. So maybe I can just put to be occupied. First chair to be occupied is chair 2. Case 3, first chair to be occupied. So you get the gist. So I'll just erase this. And so up to case n minus 2, first chair to be occupied is chair n minus 2, case n minus 1, and case n. So I'll just know you writing this. So look at case 1. So if someone is seated in the first chair, then no one can sit in the second chair, okay? By virtue of the conditions for the sitting arrangement. So it means we're left with n minus 2 chairs in which people must still be seated comfortably, okay? So someone can sit here, but within this n minus 2 chairs left, the seating must be comfortable, okay? So it must be a comfortable arrangement. So that tells us that we have, for the first case, we have, so let me use a different color maybe. Okay. So for the first case, we have xn minus 2 possibilities, okay? Because there are n minus 2 chairs and still the seating must be comfortable for the total seating to be comfortable, okay? But recall that it says at least, you must have at least one person in each of the seating arrangements, okay, at least one person. So it means if we leave this remaining n minus 2 chairs vacant, that is not a possible arrangement under xn minus 2, but that would be a possible arrangement under xn because someone is already sitting in the first chair, okay? So that would be a +1. And we see that we can apply the same idea to the others. So analogously, we have that for the second case, we'll be left with xn minus 3 chairs. And if these xn minus 3 chairs are left vacant, that is also a possibility since someone is already seated in the second chair. Up to, so let's look at the n minus 2 case. If someone is seated here, then we're just counting for x1. And if the remaining, the nth chair is left vacant, that's still a possibility, okay? So pay close to this. This was very important in defining so that we don't overcount. First chair, first chair, first chair, okay? Okay. And if the first chair to be occupied was the n minus 1th chair, then there'll be only one possibility because no one can sit in the last chair, and yeah, so basically, there's only one possibility. That's the person sitting in the n minus 1 chair. And if the first chair to be occupied is the nth chair, then it's also, as before, only one possibility. So it means xn is going to be equals to the sum of each of these cases, okay? Xn minus 2 plus 1, okay, plus x subscript n minus 3 plus 1, and so on and so forth, up to plus x1 plus 1, and then plus 2. Okay, so this gives us that xn is equal to the sum of the seating arrangements up to xn minus 2. And since there are n minus 2 ones here and then plus 2, so that will be plus n. Okay, so let's find what xn minus 1 would be. So let's just get that. So this implies that xn minus 1, so just put n minus 1 wherever we see n. x1 plus x2 plus xn minus 3 plus n minus 1. Okay, so let me just erase these cases here. So when we subtract it, we have xn minus 1 being equal to xn minus 2 plus 1. Okay, so this gives us a nice recurrence relation. Xn equals to xn minus 1 plus xn minus 2 plus 1. Okay, so Now let's, just see how this recurrence relation works, in practice. Now let's count the number of ways, of arranging. So x1 is going to be equals to 1 because we have only one seat and only one person can occupy it. x2 is going to be equal to 2 because we have 2 seats and they can be occupied. Either the first or the second seat can be occupied. x3, okay. So x3 is going to be equal to, so let's just draw our chairs. So x3 is going to be equal to, okay, let's count it. So if the first seat is occupied, so if 2 people are seated, it can only be in one possible way, first and third seat. If only one person is seated, it can be in 3 possible ways. So that'll be 4 ways. Okay. Now we see that our recurrence relation is working, as you can see here. So we see that if we put n equals 3, we'll have 3 equals to 2. Sorry, if we put n equals 3, x3 is equals to 4, x2 is 2, x1 is 1, and then plus 1. So 4 is equals to 2 plus 1 plus 1. Okay. So let's just see what x4 is before we jump into this question. So let me just erase this. So from the formula, we were expecting x4 to be 7. So let me just draw 7 4x1 grids. So if one person is seated, we have 4 possibilities. If 2 people are seated, we have 3 possibilities. So total of 7. Okay. So now, basically, if you look at this, we can find a formula. For instance, we can set xn to be equals to yn plus 1. And when we do this, when we set this, we have, so we can add 1 to both sides. So we have xn plus 1. Sorry, xn equals to yn minus 1. Okay. So we have xn plus 1 equals to xn minus 1 plus 1 plus xn minus 2 plus 1. Okay, so just added 1 to both sides. Basically adding 1 to xn and xn minus 1. Okay. So basically, if we set this sequence, so xn equals to yn minus 1, that implies yn is equals to xn plus 1. We'll have a recurrence relation that looks like Fibonacci sequence. Okay, so basically we can find a formula for this, but that's not what I'm going to do in this video. I'll just, get as many values as we can get to find which of the options is not a possible value of xn. Okay. Okay, so let's find our values. So x5 is going to be equals to, so it's going to be equals to 7 plus 4. That's 11 plus 1, 12. x6 is going to be equals to 12 plus 7, that is 19, plus 1, that is 20. So we see that 20 is a possibility. x7 is going to be equals to 20 plus 12, that is 32, plus 1, 33. So we see 33 is a possibility. x8 is going to be equals to what? 33 plus 20, that is 53 plus 1. So that's 54. So we see that 55 is not possible. X9 is going to be equals to, so let's just see that we can get the order. So X9 is going to be equal to 54 plus 33, that's 87. 87 plus 1, that's 88. Okay. X10 is going to be equals to 88 plus 54. That will be 130 plus 12, 142 plus 1, so 143. So we see that we've gotten this other one. So our answer is going for this one is going to be option C, which is 55. So that'll be all for this video. Hopefully we'll be completing the solution videos for all the rounds of the Olympiads that has been done thus far from 2020 for the senior category especially. So that'll be all. You guys should keep on solving maths. And also, I'd love to see someone get an explicit formula for xn. So goodbye, guys.